Hey guys, welcome back to the channel. I have an interesting video, this time working on 7 computers, actually coming from Sweden. This is actually very humble for me and it makes me very happy to see how far my small business has reached in the world. You know, it's amazing. I have customers from almost every corner of the world right now, except for here and there areas, but it is very nice to see that people can reach out. Distances are no longer there when you have a platform like YouTube or Google or Yahoo or anything that connects us together, right? And we can help each other. Right, so these are coming from a company, Lundin Technology AB from Sweden. Christian, these are all your computers. So I have, let me move you here, all in here so you can see I have one connected, which is the MEF4. I was working yesterday late and finished one MEF4, so that is the one I'm going to start. I think we have a MEFI2, and then MEFI3, 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 and MEFI3. So all the rest are going to be MEFI2 and 3. So I guess I'm going to start with this one to see what we find. But before we go into the repairs, I want to show you closely the information that he sent. So this is just so he can see in one view all in the bench. This is a list of the computers and concern that he has with each. My MEFI 3. Possibly look at this one first, most urgent. Well, I'm sorry, but I have a MEFI 4, so it's going to have to go as I go. I will go next on the MEFI 3s. But yeah, we have a MEFI 4 with no communication, MEFI 1. So there's a MEFI 1, not a MEFI 2. MEFI 1 and MEFI 3 is the rest. So, and then you can see Christian Lundin from Lundin Technology. And his email to me, it says, I have a small company, Lundin's Marine RD, that works with outboard engine development, and sometimes I receive ECUs and ECMs, PCMs for repair, and most of the times I manage to repair them. But regarding the MEFI units, I possess no knowledge to repair them and wonder if I can use your company to diagnose and hopefully repair them for me. At this point, I have 7 MEFI units that I would like to send you for diagnose and cost estimate for repairs if possible. Is this something? And obviously, I respond to him, and that's why they're here. All right, so let me get the Rinda, as I normally do. Let me power up the power supply. And let me put the diagram on the screen. All right, power supply is powered up. Early Saturday morning. Just got breakfast. Hopefully you all have a nice morning today. And if you're here and you have not subscribed to the channel, please do so. That really helps my small business a lot. Every time you subscribe, YouTube promotes more of my videos, and that's how you find me. It's also for free, and if you do so, I would really appreciate. Also, if you have any automotive or marine ECMs, PCMs, or instrument cluster, just copy the same name that you have in the YouTube channel here, Mike Salazar Diagnostics. Yeah, my name is spelled a little different, but it's Mike SalazarDiagnostics.com, and then you find my website. In there, you have the same repair form that he filled and signed. And just look for a white box that says "Click here to fill the form." That downloads that form. Then you have my telephone, email, address, warranty policies, cost of the tests. There is also a white black box that says "Click here to email us." Please do so. Like that, I can have your email, and we can start having a conversation on what your concerns are. What maybe do I need from you as far as maybe an extra component. In marine, not so much, but in automotive, sometimes I need a key or part of the immobilizer, VCM or so, right? Okay, let's dive into this test. All right, let me power this up, and we're going to power the computer on. I'm using the Mark 50. You can see it all in there. All right, so everything is powered up. I didn't see let me actually get all these out of here. No longer need to be in the bench, right? One has a very dent. The cover is really dent. as the, I always use the letters in here, A000, let me see, A30's number 80422. It has a very deep ding on the cover. Hopefully it's not that damaged, but we'll see. All right, so this one is a MEFI4, and the last digits on this one is letter A 31490070. All right, so let's attempt our connection. I didn't see the fuel pump, and I have everything connected, so it should have light up, and it didn't. So this is probably reading his notes. It says it's dead, no communication, but we need to reproduce the concern. So I'm going to try to establish a communication, and that is not shown in there. Yeah, now it is. Okay, so you can see this is the diagram from Rinda Technologies trying to attempt communication, and now we have the ECM is not responding or the cable is not plugged in. So we have confirmed his concern about dead, no communication. I can see that we have a sensor ground and sensor power on my simulator here. You got that green light on the bottom and the orange in here. That is for the 5-volt reference. So that means at least partially the computer is on. So I'm going to open it up and see what I see. And then we either move to the next one or give him an estimate and see if he can repair. I have explained this multiple times on videos for the MEFI4s, or actually all the MEFI families. These computers are deep in a gel. Some of the components are replaceable, some are not. So in these kind of computers, due to the fabricate, to the materials on the board, which is also like a hybrid ceramic board, it's not a regular, I don't know, like a multi-layer board, which it is a multi-layer board, but it's printed in a ceramic board. So that makes it very hard. So you can remove and install components just so many times. So I have, in these cases, to either attempt to repair it, and if it works, perfect, and if it doesn't, then it's done. I always do the check as far as voltages, and I have showed that multiple times. I am actually removing that more and more because there is a lot of companies everywhere trying to copy what I do, and I don't want to remove myself from the equation, right? So hopefully you understand that. So I'm going to, let me do my testing here. And then I'm going to move along to the next computers. I might have to shrink the videos or make part 1, 2, 3 for him. The reasons of these videos are going to be tests, and hopefully before and after for each computer. Like that we can see what is the results. These computers are most all over the world deemed as not repairable by anyone else. I'm probably one of the unique companies that can actually fix them, and I have very, very good success rate. But there is always a limitation, right? So the materials and some of the components on this board makes it very hard. Some are crystal components that cannot be replaced. And if one of them is bad, that is the end of the computer. But at least you will know for sure that that computer is definitely not repairable 100%. All right, let's dive into that. And this is going to be what you will be seeing in here. Me connecting a computer. Probably going alone, wiring diagrams, especially if I can make it talk, so we can give recommendations to the customers to what to correct in the boat, and then go from there. Right? And this is the experience you will find if you send any computers for repair here. And I always said, I do most of the computers videos. I have some repairs that I don't because it's just too quick. It will be more time to me for do the connections and videos and everything that what I'm actually charging. So when it's something that is a certain amount, I don't do it. And I hope you understand that it's just it's sometimes hard. I got a lot of work, so if I start recording minimum repairs, I will be here just recording videos and I'm not working right. So hopefully you understand that too. All right, let me dive into this one, and if I see something that I need to bring to your attention, I will be coming back. Okay, be right back. All right, guys. Yep, not a good luck with this MEFI4. Press the wrong button here. Give me 1 second. So yeah, I try everything I know that I can do. The actual computer has all the voltage rails across the board, including around the microprocessor. But yeah, something else is there that I cannot see. It might be even in between the layers or a signal that needs to start the microprocessor. I even try the crystal oscillators and everything, but all the signals are there. So yeah, like I said, either a bad microprocessor, which is in this case not repairable. And the microprocessor on this board is this component here. As you can see, it's kind of like a blue or so on your screen. That is a crystal material component. So they're decided to do that in this board, and it's like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, like 9 of those components around the board, and the rest is not a problem. I can replace and reinstall, but not in this case. All right, so we're going to move along. I'm going to have to remove, this is a connector for MEFI4. So I'm going to disconnect this computer, follow along on the next one. We have how many minutes? Only 10 minutes on this one. So I think I can probably try to attempt the next one that he said it was the most important. So we move into that one. This one is a no-go. All right, be right back. All right, guys, this is going to be probably 2 computers per video, so I don't make it too long. So this is the one he requested to see first, although I have the MEFI4 connected first. It says most urgent. This is supposed to be a 5.0 TVI. I didn't have any information on the MEFI4. I don't know what kind of boat or anything it was, but yeah, no matter what, it's no longer important. This one says calibration 9E06. So this is a Volvo Penta. Whenever you see a sticker like this in a computer, that is a Volvo Penta, and indeed it's a 5.0. We don't have any more information as far as hours or nothing like that, but let's plug that in. I have everything off, so no problem to plug in the stuff. That's my lovely dog that likes to bark for everything. His name is Bruno. We call him Hannibal Lecter because he's a little psycho. All right. Okay, so let's power up and see if we have fuel pump or not. Well, this one does have fuel pump. Let me see the notes on that one. It says, has problem with fireboard reference. It is dead. If possible, please look at this one. Most urgent. Well, I have fireboard reference and sensor ground and everything so far. Let me connect the oscilloscope. See if it runs. All right, let's attempt connection first. Make sure you guys are seeing that. Yes, you are. And same thing, MEFI 1 to 4. Detecting the ECM and detects it. Mode 1, standard diagnostics, and we connect. And it has 0 trouble codes. So we got nothing to go by. Yeah, the calibration is 9E0Z, and he most likely knew that because obvious reasons, because the only way to read the calibration on the Volvo Pentas is when you connect to the computer itself. So let me connect the oscilloscope and save this data. I connected the oscilloscope, so we'll see if it runs what we have here, right? So let me inject the signal. Yeah, I can definitely see it running. I don't see coil, and that might be because this, well, no, this is a Volvo Penta. But we do have, let me adjust the idle. I'm just raising the RPMs because the computer is seeing RPMs. Just trying to get to 600 RPMs at least. And let me get that to you guys so you can see that too. But we do have RPMs. The computer is reading minutes of the engine running. Let me make sure I got all my connections done properly here because I got the EST at last connected, and then I'm not sure if it's fitted perfect. Well, actually, I can do that here, but I'm going to have to turn the ignition off and turn that off. And I can definitely see the computer seeing RPM because otherwise the fuel pump will not be on. Yeah, this was connected proper. Power here. have the coil unplugged. You see the coil connected for. I have the coil connected for the MEF Cruiser system and not for the MEFI Bobo Penta. So let's try one more time. Mission on. And I have, everything in there. Let me reconnect, because as you see, since I turn them off, we lost the communication. Let me put that RPM pit in there so you can get to see that. And let's run it. Yeah, right now we got coil and injectors. Although, let me see the signal. Because as it is, the oscilloscope is connected to one of the injectors and to the coil. But the coil activation, it looks like it's not right. Let me get more time in here. Yeah, it's like it's completely fully grounded. Yeah, I guess it's like it does fire, but it doesn't fire properly. Injectors, they seem to be running good. I'm going to move the other channel to the injector. And you can see the readings. So now the A channel, which is the blue, and then the B channel, which is the red, they have the measurements right at the bottom. So I put those on purpose. We got a maximum of battery voltage and then a minimum of ground. The pulse width on the blue channel is 1.2 milliseconds, and that all depends on how much I got as far as manifold air pressure, and so it should be okay. Well, actually, it's a little low, 11.9. So let me bring that up to 12.6, which is usually what I use for my tests. So that is around there. We have 5.5 of throttle position. Again, a little low, not too much. I like to see between 7 to 10%. Yeah, but everything else looks good. I just don't like that signal of the coil. And obviously that is the computer. It's a little weird that it's seeing the signal because and it's firing like that because injectors are correct. And then but the coil is not. So I'm going to move the blue channel over to the coil because in the blue channel is the one I have the readings for the milliseconds. And we can see that now when I connected that, it's reading completely down to ground. And the pulse width is 0 because it's completely shorted. Or the coil is on all the time. This will burn the coil. So yeah, I'm going to have to open the computer to see exactly what we have here. Let me see if I have a Bobo Penta to connect this so you can to check my connections as well. Give me 1 second. All right, so I do have one of my Bobo Pentas. This one has no fuel pump, but it's a good computer. So I got, as you see, let me get that closer to there. It's a little hard sometimes for these cameras to focus, but I'm going to turn this off. We're going to lose communication. All right, let me unplug this computer, his computer. What I want to do is make sure that everything that I have connected is connected properly. So this is again, here's with the sticker I'm going to keep here, at least there. And let me connect this in here. Mine. Let me ignition on. You can see there is no fuel pump in that computer, but for the rest, that computer works very good. So let me connect to Diacom. You see it's detecting the computer good. And we're going to communicate or to connect. This one is a different calibration. This is a 9D14, but it's a Bobo Penta 5.0. I remember Bobo Penta has GXI, OSI, it's just multiple different things. Yeah, definitely we can see. Yeah, you can see right there the coil in the blue channel. I'm going to just go up to the 600 RPMs, which right now you cannot see. Let me get some glass so you can see We are in 346 RPM. So I'm raising the RPMs to 600. Oops, that was already there. Okay, we're in 600. And what I want you to see is now the difference. So we have, so my connections and everything is good. So I do this on purpose when I can, right? Because not all the time I have a computer that I can connect and show. But my connections, my ignition module, everything is good. And we can see that in his computer, we have no coil. The coil is actually completely grounded. And that is, it's hard to think that it's going to be able to be repaired because these computers, the ESD component is crystal, but we'll see. I have still got to open to see if I find something, you know, like I don't know, a broken wire or something that is the one is doing the problem. Let me open it up and I'll be right back, guys. But at least you can see that my connections are all good, and I have a lot of MEFI3s on his that we can quickly start doing the same thing without taking that much of your time. So far we have 20 minutes, so around 10 minutes per computer. So let me open this up and I'll be right back, guys. All right, guys, I think I got good luck with this one. Like I said, you know, every module is going to be repaired or not done because I cannot do anything else. Yeah, this module was full of grease. Got it on my face now. All right, so let's connect to the computer. Let me actually power off and start from scratch like I normally do. Yeah, you can see everything in there. So we're going to power on. So you can see the fuel pump relay, and these computer last part numbers are A00078976, which is the one he marked as, if possible, look at this one first. All right, so let me connect to DICOM. We can see he's, let me actually put 2 pits. I'm going to put, for now, the RPM and also the calibration checksum. I need to put the other pit in here, which I think is this one. Yeah, I got to reselect it on the software because it's showing both the same. P1 calibration. Yep, now you can see the calibration checksum in there. I'm going to move it down so it's not in the way of anything else. But yeah, so he can see that this is his calibration checksum that we were testing before, and it was actually acting weird. So I'm going to run it. And now we can see on the blue channel what we saw in my computer, a nice and normal coil activation. We can see also, you can see it on the blue light in here, how now it's flickering. Before it was steady. Let's raise the idle to 600. Disregard those little bumps in there on the signal because it happens when I click on the mark 50. It's a digital button, so it's a little weird. They should have put a knob in here for the RPM so we can slowly do that. And then go back to 600, come on. Okay, now we're in 600. Okay, I want to make sure that that signal stays. See, we're getting here and there a not good signal. It is happening again. You see it's coming back. I'm going to have to work a little more. So give me a second, guys, to work a little more on this signal because we can see that it is working. I have to do my magic again in there, but let me see if it works and I'll be right back. All right, guys. So, yep, no, another computer that is not repairable. So, yeah, it looks like a hole he has in is probably not going to be a good repairs. Yeah, so I'm going to share at least some information so you get to understand more of this circuits. So on the image you see right now on the left side of the screen is the actual ESC module for these computers and the signals for MEFI 1 or 3. So we're going to stick with the MEFI 1, sorry, MEFI 3. But let me just read. It says, when the system is running on the ignition module or in crank mode, there is no voltage on circuit 424. I want to show you that circuit 424 is, in this case, if we go over to what it says, MEFI3, I'm not sure if you can see that. Let me just 1 second. Yeah, no, you can. I cannot even hover with the with a mouse because it's an image that I'm sharing with you. So on the image that you see there in the upper part, where all the letters are, and then you see the diagram. On the right side of there, you see what it says ECM. It says MEFI1, and on the right says MEFI3. It says MEFI3 J110, J210, J124, and J13. Those are the pins. Connector J1, pin 10, connector J2, pin 10, connector J1, pin 24, and connector J1, pin 3. And then they name those circuits, again, engineers, and instead to just say, J1 circuit or whatever, yeah, they call that circuit 424, 423. So circuit 424, if we see closely on that image, is on pin J124. Circuit 423 is, if we again closely look into that, is in J1 pin 10. And then I follow the other one because the J210, which is circuit 430, is not being discussed in this image that I'm sharing with you, but it's also a very important signal. So in the RPMs, I'm going to get to at least select the RPM pit so now you can see, or we can see all where exactly are we as far as RPMs. Yes, that's perfect. Because it's not going to be much in our way, because I'm not sharing the diagram so we can see better, or you got less stuff in the screen. So right now the coil firing normal and isn't 320 RPM. So actually we will see that it's the same thing in 295 RPM. So I'm going to read those signals or show you how those signals are based on that RPM. So let me get myself here. So I'm going to go into pin J110. No, right. Let me see. Yeah, J110. So J110 says when the J110 should be circuit 423. It says when the system is running on the ignition module or in crank mode, there is no voltage on circuit 424. And the ignition module ground circuit 423. So we are in circuit 423, which is J110. If we see the values right at the bottom, they're like a half a volt, so, or 0. Let me actually make those readings a little bigger because we can barely see that. So let me go into large. Yeah, that's better, right? Yeah, a lot better. And let me put that in here so I can see what we're discussing. So let me go back into the J110 right here. So we see that we have around 430 millivolts in there. If I increase the RPMs, which I'm going to do, let's go over to like where we see that we lost the coil signal and see if that voltage change. It should have changed to now something else before or higher than half a volt or ground, because the computer is expecting to see now on the circuit 423 voltage, and we have 4.4 volts. So we see it says when the RPMs of the IC is reach about 330, circuit 424 voltage is applied. Circuit 423 should no longer be grounded in the ignition module, and the voltage should be varying. So it's not a varying voltage, but it's because the computer is not receiving the signal. And I'm going to show you that. Let's now check the other signal. I'm going to come down to where we can see the coil working, right? So that's good enough. Now we're going to check circuit 424. Circuit 424 should be J124. And in J124, right now we have ground. It says when the system is running on the ignition module or in crank mode, let's say now we're in crank mode, there should be no voltage on circuit 424, and there is not. So if I increase the RPMs, I'm going to do that to see the change. See, right now we have a varying voltage and it went up to 4.4 volts. So both circuit 422 and 423 are intact, at least to that, module. The next one is, like I said, is the same RPM signal that we're seeing, or not RPM, sorry, the coil signal. I'm going to bring it down because right now it's kind of like working. You see 495, but it does try to work. And this is definitely a bad driver. You see how right now it's shorting and it's shorting and now it's completely shorted. Now it's not. And I'm not doing anything. So I'm going to bring it down to the cranking mode where we can see the activations better. And I'm going to go over to the J210, which is on the other side of the computer. Let me just find it. I think it's in here. So that signal is pretty much a copy of the activation that we can see on the coil, right? Because the blue channel is connected to the coil firing on the load box. And we can see how that one matches pretty much the same, right? So I need now to find that same circuit or that same signal to see, are we missing that signal all the way to the IC or the ESC, which is, let me get the light out. This is the IC that I have uncovered right here. And looking at that signal, which I know exactly where it is, give me just 1 second to locate it again with a microscope. Okay. I'm going to show you right now the signal right here. So the signal is intact in there. I'm going to hold that, and well, it's a little hard to do with one hand. Yeah, right there, I'm good. I'm going to move the light so you can see where I have that token in there, right? So right at the IC. And I'm going to increase the RPM to see if we lose that signal. Let's keep an eye on the blue channel. You see how it's exactly a same signal up in the top, same signal on the bottom. So we're going to go over 600 RPMs, which looks like it's the magic number for that one to fail. And we can see how the signal, the red signal, is still there. So the coil should not be, now it's actually not even grounded. You see now it's not grounded. I think I went probably, did I went too high? Let's see 1 second, guys, so because to see if that we have no faults, make sure that we got the shift circuit here. Can I see it on my glasses? Too many things on the way. Yep, the first cable, and it's there. I'm gonna remove it and see if that kills the running. It didn't. Let me raise up the RPMs. And now it's fully grounded. So it's not about the, I wanted to share or to check, sorry, the shift switch. We can see how it's now working. And again, it's just very intermittent. Now it's fully grounded. Yeah, nothing to do with the shift signal or shift interrupt. I'm just trying to see, because since I don't have all the designations and serials of the engines, I don't know exactly what am I dealing with, right? And based on that calibration checksum, is not enough. So, but what I want to see is that red signal. that red signal is there. So that IC is receiving the signals. All the signals, they have not changed, and they do change when they need to do as the RPM is there. We know that those signals, my ignition modules are good, because we connect the other computer and it's working good, but this one is not really acting up. I'm going to try one more last thing. Give me just 1 second, guys. All right, so what I was doing is just exposing that signal a little more closer to that IC to see if we're missing it. But yeah, no, closer to the IC, we got the signal, and then the coil is now shorted 100%. I'm in like the same 500 or so RPM. You see, it just came back, and it's something internally in this IC is creating the problem. And sadly, but that is very intermittent. Right now, it's working. You see right there. So it's not that we're missing a signal. It's something definitely happening internally into that IC that is creating the issues. It would get to to work perfectly like this for forever. Because sometimes breaking on paths can create these issues. Actually working really good now. 3,000 RPMs. We can get, it is still crashing, You see crashing. Nope. Yeah, now fully shorted. This will cook that coil instantly. Right now, again, now it's not even firing. And it has nothing to do with the RPMs or the signals. They're all there. Again, that signal, that red signal that we need to have in there. And I am pretty sure, pretty close to the IC in this case. Let me move some of the stuff that you can see. I'm still poking in there in the red signal. And the coil now when fully grounded, you see, without we're not losing nothing. Change on that amplitude of that waveform, which is exactly what I'm trying to analyze. If we get to lower RPMs, when this works, is the amplitude on that rate on the red signal getting bigger or smaller? No, it's not. So it's nothing to do with the actual signals or all the way to there. I'm sorry, Christian, but yeah, another not repairable computer. I'm going to have to stop here. We already got 38 minutes, more than what I really wanted to do, but at least I think I show more information, very important information that is good to have for all of you. If you have a MEFI3 and a MEF4, so now you know that I am definitely an expert on all this. This is not a guesswork. I acquired all the knowledge, and I can show you quickly where to go. Well, kind of quickly. Well, 2 computers, I think it's not really so bad. I'm trying to not make too many videos for something that is so far not a good conclusion on any. And I was expecting something like this, a repair facility from someplace else. One of the computers or some of the computers are open, not all are open, so I cannot really say that he was trying to repair them, but I'm not sure exactly how the damage was. We got absolutely no history. He just sent computers with his note about no fiber reference or it's dead. This one, the one we are just having in here, it says has problems with the fiber reference. This is no problems on the fiber reference. The problem is an RPM. The coil is shorted. So a completely different description of what he has there, and I can show you right now. The fiber reference we can see right there. Look at the fiber reference. I had it on the red channel. It's 5.1, 5.2 volts. How is that fiber reference? Perfect. There is absolutely nothing wrong with that fiber reference. So yep, another not good conclusive repair or test, but at least good information. I hope that you like the content.
Stay tuned for the rest. I'm going to probably move into another computer that I have more work to do. I cannot focus only on to one customer. At least I can get the ball rolling on him, but otherwise he will take my entire day, and that's not good. Also, by the way, I'm going over to an Alaska trip on September 7th. This is 2025, so if you have any computers that you need to repair, please send it right away. Otherwise, it's going to have to stay till here until I come back, which is probably until I think it's the 17th or the 19th. So we're going out for like 10 or 12 days. So obviously, we're taking a fly over to Washington and then a cruise ship and then Alaska. So you'll see some of the photos. I might be able to share some and short videos in my YouTube channel. I like to sometimes to share what I'm going and what I'm doing. All right, guys. Thank you so much for visiting the channel. See you next time. Bye bye.